Hey there, TouchDesigner developers, Jack Delora here. Today we're going to look at building this cool instancing-based setup that you see on screen now and working with a new app called ZigCam to add some control to it based on the position of our head. So ZigCam allows you to send the camera image from an iPad or an iPhone along with some interesting tracking information like face tracking and body tracking all over NDI to any app that supports it. So again, we're going to use that here to allow us to modify our camera position within this setup that we have. So we actually have a ton to cover. And so let's begin by deleting everything within this network, starting fresh. And we actually have to jump into a laundry list of things to set up beforehand, starting with, of course, downloading ZigCam onto your device. So again, that's an iPhone or an iPad only, unfortunately. So make sure you have that downloaded on your device. And then within the ZigCam app, head to the settings page where you're going to set the tracking mode to face tracking because that's the kind of tracking we're using for this particular example. After that, set the image scale to 3. That just reduces the quality of the image that's being sent over NDI. And then we'll head to step 3 once you've got that set up. It's very important to make sure that both your device and your computer are on the same Wi-Fi network. Otherwise, your device won't be able to send the information to Touch. So double check that if something isn't functioning. Step 4, device placement is also important. So there's 3 things to keep in mind for this particular example. First of all, your device, whatever it is, needs to be in the landscape orientation that we see here with the front-facing camera on the left. So we're using the front-facing camera for our project today. We also need to roughly align that camera with the center of our computer screen. So you can see here I've got that roughly aligned with my monitor behind it. And number 3, our device needs to be secure, as in it won't move during our testing. So that'll just make it, if it starts to move around, that makes it a lot harder to kind of get consistent tracking as to where our head is moving to and from. So I've used a cheap little tripod here to kind of secure my phone and set it up in a specific position. You might be able to just lean it on something. But whatever you do, those are kind of the 3 things to keep in mind as you're setting this up for our project today. So then for our 5th and final step, you're going to head over to GitHub and download some files quickly. So this link should be in the description below. Head to that page, hit the green code button, then hit download zip to get these files downloaded as a zip file. And then if we head back to Touch and then grab our file explorer, you should see this kind of file directory once you've unzipped those files. Head into the sample TouchDesigner folder, and you'll see that we have one here called ZigCam receiver.tox. That's what we're actually going to use in our project. I also want to point out that the project that we're building today is somewhat inspired by this ZigCam AR view network that we have above. So definitely check that out just to get another example of how to use ZigCam with Touch. But anyways, we're going to be dealing with this receiver tox. So let's click and drag that into our network now and get to work within TouchDesigner. So the ZigCam receiver needs 2 things at its input. And the first is an NDI in top. So I'll put that into the network and connect it to the first input. Within the NDI in top, we will look for our particular device. So assuming that you've got your device connected to the same Wi-Fi network and you've got ZigCam running, when you hit the send NDI button in ZigCam, we should be able to find our device within this source name parameter. And you can see that my phone has popped up right here. So I'm going to click on that. And if we give it a moment, we should see a very blurry version of our camera image coming in. Now, I don't particularly care about the image because we're not going to be using it for anything in this example. So I'm going to turn my bandwidth here to low, and I'm also going to turn hardware decode on. And now that I've got those things set up, I need to also grab an info dat so we can get our tracking information from the NDI signal. So once you've got the info dat in your network, just click and drag the NDI in top onto the info dat. And then we'll connect that to the second input of our ZigCam receiver. Once we do that, you should see the error message disappear. And then if we connect a select chop to the fourth output, we should see all kinds of different chop channels coming out of our ZigCam receiver. So you can see that we're getting kind of weird, glitchy data right now. And this happens sometimes, at least with my particular device. When this happens, I find that the best way to kind of reset the system is to close ZigCam on your phone and reopen it. So I'm going to do that now and hit send to NDI, and hopefully that will fix the channels here. There we go. So now we can see that as I move my head around, we're getting data that is kind of looking a little bit more normal and based on my movement. So cool. We only need one channel of all this tracking information, but I do want to point out, the amount of kind of depth that you can get into here. We have tons of things related to our eye position, our mouth position, even our eyebrows and our jaw. You can really dig in and get some very interesting control information just from using this free version of ZigCam. So for our purposes, we only need one channel of data, as I was mentioning, and that is face_RY. So we'll click that, and we should have now one chop channel of information that corresponds to the left and right rotation of my face as I move. So cool, we've got that set up. I want to filter this data slightly so that the changes are a little bit more smooth. So I'll add the filter here, and you can see that that kind of smooths out those changes as I move. And I will then attach a null to that because we're going to use this chop channel for a chop execute dat in just a moment. Before we do that, though, I'd like to add a constant chop over to the right because this is what we're going to modify with our chop execute. I'm also going to change the name of the first channel here to XPOS. This is going to move the position of a couple of things later on in our network. And then once we've done that, I'm going to right click on the output of null1, head to the dat page, grab a chop execute, add that to our network. Make sure that we've got null1 in the chops parameter and value change on. And then I'll open that in an external code editor and we can add some code. So here's the final version of our code just for the sake of time. Go ahead and pause the video here and write down these 4 lines. Everything is found within our onValueChange function. And basically what we're doing here is when our face_RY channel is either below -5 or above 8, we will set our constant chop accordingly. So basically what I did was I looked at the value of this channel when I'm looking at the left edge of the screen and the right edge of the screen. I kind of found like an average value for that channel when I look in one of those directions. And I use that as the kind of limit here within which, like when I cross this point, then I'll change this constant chops value. I'm doing this to kind of limit the amount of changes that will happen later on and set up like a point at which our TouchDesigner network considers me looking to the left or looking to the right. So what you'll have to do here is take a look at the output of this chop channel. And again, depending on your setup, these values might have to be a little bit different. So just look towards the left and right edges of your screen and tune these values accordingly. The first one in the first if statement will be the left edge of the screen, and the one in the second if statement will be the right edge of the screen. Now that we've got that set up, and assuming that my microphone isn't blocking my tracking too badly, we should see that when I turn my head to the left and the right, our constant chop updates accordingly. And now that we've done that, we can actually take this chop information and kind of rearrange it a little bit and change it up for some different applications within our network. So the first thing I'm going to do is attach a math chop, and we'll put that kind of up here somewhere. Within our math chop, let's head to the mult add page where I'm going to multiply this by a value of 0.5. Then let's hook up a filter chop. And within the filter chop, I'll set the filter width here to 2. And then let's hook up a lag chop and make a couple of changes here as well. Kind of move those a little bit closer together. So we'll set our lag value here to 0.4 and our overshoot we'll take to 0.75. Cool. And then I'll attach a null to that. And we're going to be using this channel to adjust our camera position. So I'm going to call this null space cam space ADJ for adjustment. We'll use this as kind of the basis for the next two branches of the network. So let's go ahead and copy, paste that below. And within the next branch, let's head to the math chop and set our multiply here to 0.02. We'll leave the filter alone. Within the lag chop, let's set our lag value to 0.2 for both parameters. And then our null can be renamed to null space POS space ADJ. We're going to use this to slightly modify the position of our instances that we'll set up in a minute. Then we can copy and paste that again and actually delete the lag in this case. Then we'll come back to the math chop, set our multiply to 0.25, come to the filter chop, set our filter width to 1, and then within our null, let's just rename that to null space COL for color space ADJ for adjustment. Cool. So now that we've got that set up, we can actually start working on our visual component of our network. Okay, so we're going to start off with some Sop geometry, which will kind of place directly above what we set up here. So I'm going to begin with a box Sop. And again, we'll just put that somewhere up above that. Within our scale parameter, we're going to set this to something really small, 0.01 in this case. And then our next operator will be a line Sop. So we're going to use the line Sop to make two copies of this box. So within the line Sop, my point B parameter, I'm going to change the X value to 0.02. And then we're going to connect both of these things to a copy Sop. You're not going to be able to see a whole lot in the viewer at this point, but trust me, something is happening, and we'll see it in our render in a minute. So we'll connect those things to the copy and add a null, and then we can right click on the output of the null and grab a geometry comp. Cool. So we're still not seeing much, but that's okay. We'll again move on and add a camera and make a couple of adjustments within the camera. Let's set our translate parameter in the Z direction to 0.8. And we'll come back to this for more later on, actually. Above that, I'm going to add a null comp, which we're going to use for our position adjustments, just to make things a little bit easier. We're not going to do anything within that at the moment, but I am going to connect the parent and child connection there. So just drag from the bottom of the null 3 to the camera 1's top input. Once you've got that set up, let's add some lighting, and then we can add our render and start seeing our output. So we're going to use two lights in this case. So I'm going to add light 1 and then copy and paste that for light number 2. Within the first one, all we need to do is adjust our position. So let's set our translate value to 0 in the X, 1 in the Y, and 0 in the Z. Light number 2 is going to need a couple more adjustments than that. So let's head there now. First of all, in the translate parameter, we want -3 in the Y direction and 0 in the Z. We also want to rotate our camera in the X direction so that it's pointing upwards. So we're going to rotate by 90 degrees. Then we're going to head to the light page and change the type of light that we're using. Instead of a point light, we're going to use a cone light. We're going to set our cone angle to 145. And now that we've got that set up, let's, add a render top now so we can just see our output. And then we'll work on our material. So once we've done that, we should see 2 cubes on screen, nothing too fancy yet. And we can now add in our material. So we're going to use a PBR. And unlike usual, we're actually not going to use an environment light in this case. We're going to use these lights as our lighting instead. So I'm going to click and drag our PBR matte onto our geo and hit parm material. and then we'll come back to the PBR and make a couple of changes. So the only thing that we're going to modify here is just setting our roughness to 0.1. Cool. So we've got those things set up, and nothing too fancy is happening yet because we haven't started instancing. So why don't we jump into that next? We're going to be using some noise tops for instancing. So let's add a noise top right here and make some changes with that first. So before we do anything with the aesthetic, let's head to the common page and set our output resolution. So we're going to do 120 by 120 in this case, and we'll set our pixel format here to 32-bit float RGBA. Head back to the noise page after that, and we'll set our seed to 99, and then we'll come down to amplitude and set that to 0.75 and our offset to 0. Finally, let's turn monochrome off. We're going to use this one to generate positions for our instances. After that, we'll hook up a null and rename that null to null space POS, because that's, again, going to generate the positions of each one of our instances. So we have some instance information, and so we can actually head to the instance page now. Within our geocomp, turn instancing on, drag null POS into our translate operator, and then grab the RGB channels from that operator. Once we've done that, we should be seeing some copies of our geometry. And also, one thing that I'm realizing we forgot to do is add a small amount of animation to our noise so that these positions will kind of change over time. So on the transform page, let's head to the translate parameter, the TZ parameter specifically, and we'll type in here ABS time dot seconds, and then we'll multiply that by a very small value of 0.0025 and hit enter. And now those should be slightly shifting over time and gives us a little bit more of a dynamic composition on screen. Cool, so now we can move on to our next noise top. Just to make it easier on ourselves, I'm actually just going to copy and paste what we have already so we don't have to reset our resolution and all that stuff. In this noise top, let's head back to the noise page. We'll set our seed to something else. I'm going to do like 5. We'll set our amplitude to a value of 720, way down at the bottom. And then our offset will stay the same, but then we do need to come to our transform page and make a small adjustment here. So instead of multiplying by 0.0025, I'm going to make a slight change and make this 0.001 and hit enter. Then I'm going to come to the null and rename that to null space ROT for rotation. And then we can add that into our instancing setup as well. So I'm going to drag that into the rotate operator, grab the RGB channels for the X, Y, and Z parameters respectively. And now we should see some very nice looking rotation on screen. So cool, we're getting somewhere with our visual output. Let's copy and paste that, and again, make some modifications to the noise top. So let's head back to the noise page where we'll set our seed a little bit differently again. I'm going to set that to 15 this time. Then I'm going to adjust our amplitude here to a value of 2. And then we'll set our offset to 0.5. I also want to make sure to turn my monochrome switch on in this case. We're going to use a black and white output. Finally, let's head back to the transform page where I'm going to modify our ABS time seconds expression. In this case, I'm going to multiply it by a value of 0.01 instead, so it moves a little bit more quickly. Finally, I'm going to change the name of this null to null space scale, because we're going to use this for scaling our instances, and then we'll drag the null scale top into the scale operator and grab the RGB channels for the scale X, Y, and Z. Now we should see a little bit more variety in the scaling of what we have on screen. Very cool. So now let's add some color to our operators, or our instances rather. So I'm going to copy this once again, and then we'll come into noise number 4 and make some changes. So first, let's head back to the noise page. where I'm going to change our seed once again to, I don't know, 5755. Sounds good to me. Let's set our period to a higher value, in this case of 5. Then I'm going to set my exponent to 0.75, my amplitude to 0.5, and we'll leave the offset alone. And then I actually want this to be color, so I'm going to turn monochrome off. Finally, let's come to the transform page. I'm actually going to delete the ABS time.seconds expression altogether and leave that at a value of 0. We're going to use our ZigCam setup in a moment to adjust that parameter. Then let's come to our null and rename that to null space color for applying color to our instances. Then head to the geocomp, head to the instance 2 page and drag in null color to the color operator, and then we'll grab the RGB channels for the RGB parameters. Once we've done that, we should see a nice colorful version of our image, which looks, somewhere in the ballpark of what we had at the beginning. We've got a couple of other things we want to do with this before we're finished though. But right now we might as well, since we've got everything kind of set up in our network, apply the chop channels that we set up earlier to the components within our network. So first of all, I'm just going to move everything a little bit closer so we don't have to kind of scroll around so far. Once you've done that, these are basically going to be straight chop references. We don't really have to do all that much here. So first of all, let's come to our null, where we're going to apply our camera adjust chop channel. So I'm going to turn on the viewer active, click and drag, and make a chop reference to our translate X parameter. So I'm going to hit chop reference, and now our camera position should move when we move our head left and right. The next one is the null underscore POS adjustment, and we want to apply that to our noise number 1. So let's head to noise 1, the transform page, and we're going to make a chop reference to our translate X parameter here. So let's do that really quickly. And then finally, we have our color adjust. So again, I'm going to turn on viewer active, head to noise number 4, and we're going to make a chop reference again to the translate X parameter here as well. So now that we've got that set up, let's add our final kind of visual effects, which will wrap up this example and close out this video. So we're going to start off with some fog within our camera. So within the camera, let's head to the settings page. We're going to turn fog to exponential. I'm going to set my fog density here to 0.325, and then I'm also going to adjust my fog color and alpha. So I'm going to reduce the fog color to a darker gray color with 0.2 in all channels. And then I'm going to set my fog alpha to a very low value of 0.06. We're going to use some bloom later on, which will kind of accentuate the minimal amount of fog that we're adding in. Now that we've done that, I'm actually going to add a very simple depth of field sort of effect with the depth top. And so we're going to drag that in, then we'll drag our render top onto the depth top. And we need to make a couple of adjustments here. So I'm going to set my pixel format to 32-bit float RGBA, set the depth space to rearranged from camera space. And then I'm going to set my range from to 0.5 to 1.5 and hit enter. And we should see a little bit more of a dark and contrasty image, which will give us a better sort of depth of field look in our output. Then I'm going to hook that up to a Luma blur. And we'll have both of those connected to the two inputs. Within the Luma blur, I'm going to set my black filter width to something like 15 or 20. Maybe to start. Let's see how that looks. And my white filter width to 1. What this should essentially do is blur the things that are closer to the camera and leave the things that are further away from the camera in sort of sharp focus. So kind of adjust that to taste. You might need to reduce the black filter width to something lower, maybe like 7.5 or maybe 10 to get that kind of look. I might just start with 10. Either way, now that we've got the Luma blur set up, let's actually add in the bloom effect. So we're going to grab this from the palette. So I hit Control B to open the palette. We'll head to image filters, And then we will grab Bloom, which is the first one there, and drag that into our network. And we'll connect that to the Luma Blur, to the first input. And then I'll close the palette. Okay, so within Luma Blur, we're just going to kind of rapid fire through these different settings quickly. So I'm going to set my threshold here to 0.03, my intensity to 0.94, my bloom level to 0.03, my glow level to 0.68. I'm going to set the glow color to white, so we're just going to hit 1 and 1 for the R and G color parameters. Then I'm going to set my ramp glow level to 0. And with that, we should have something that looks closer to what we saw at the beginning. The other thing that I want to do here is add in a constant to kind of tone this down a little bit and composite this underneath. So I'm going to add that below, and we'll connect that to the Luma Blur. And then I want to reset my color parameter here to a very, very dark gray. So we're going to use 0.1 in the RGB channels there. Once we've done that, let's go ahead and composite those two things together. So I'm going to add a composite top and then select both of those and connect that to the input. Within the composite, let's set our operation to over. And finally, attach a null to the end. So assuming that you've got all that set up, we should now see something that looks very close to what we saw at the beginning. Hopefully this will kind of illustrate how we can start using these devices in place of some of the stuff we've had to use in the past, like the Kinect. It actually can give us very advanced and maybe even more detailed tracking information than was available on those sorts of things. So that's it for this tutorial. Hope you got some cool ideas from it, and thanks for watching.
Hey guys, thanks for watching. If you're serious about taking your TouchDesigner and interactive skills to the next level, I highly recommend you check out the Interactive and Immersive HQ Pro. It's the only educational resource and community of its kind for TouchDesigner and interactive professionals. You can learn more by checking out the link in the description. And if you like this video, don't forget to hit that like button. And if you're new here, don't forget to hit subscribe and the little bell icon for more awesome free content.